Hello, everybody. I hope you had a great day. I'm not going to keep you waiting. We'll just get right in and let's dive right in. So, the project that I've submitted was just a study of musical training and its influences on conditioned reflexes in people who are experiencing periods of critical neuroplasticity. So, that means young people, because young people often have more sensitive cycles of neuroplasticity, and that's normal. So, I wanted to see how musical strain and musical training would affect them and how their brains develop. So some background is that as humanity's gotten more advanced, music has as well. So musicians' brains need to develop further to achieve that musical excellence. So in this experiment, we want to focus on how it affects the brain's visual interpretation and its memory. So sight reading is reading musical notation and playing your instrument at the same time. And as you can imagine, it's caused a lot of strain on people's brains because it's a lot of areas working together at the same time. So it results in many different conditioned reflexes. Now, conditioned reflex is just an action that's built through training and repetition. One example of this is calligraphy and developing perfect handwriting in which you practice for hours and hours and hours. And similar to calligraphy, musical training is the same principle, and you develop it over time by repetition and practice. So procedure and methods. This is the process, the logic, the materials, and the training and testing methods. So a code of 26 characters, I made a cipher. It was just a bunch of random characters, and where they were all assigned for the English alphabet. So then 31 character long phrases were then transferred from English into this cipher. Then 13 individuals for each level of independent variable from 14 to 18 because you want that key age of neuro sensitive cycles were selected, and one group was musically trained, and another group was just a control. They had no musical training. Then they were required or instructed to decipher the coded phrases and back into English with an assistance of a key. They were basically just deciphering, and then they were timed on how long it would take them, and then they were scored after the testing had concluded by me. So statistical analysis. At this point in scientific rigor, mean, median, and mode is not enough. You need descriptive and inferential stats like mean, median, mode, t-tests, chi-squares, all that stuff. So when you talk about descriptive stats, you can see that the the research hypothesis stating that the musically trained group would be faster was correct. I discarded the scores because they were not very different in the means, but however these had very different means, so I decided to roll with this data. So then when you see the variance and standard deviations are very low with both of these groups, and none of the data fell out of the second SD range, which meant that the data had not many outliers and it was very precise. A t-test, you can ignore that formula, it's kind of a mess, was performed on the data at a 0.05 level of significance with 50 degrees of freedom, and the calculated t-value was greater than the table t-value. And all this means is that this data was most likely not caused by chance and error and was actually a result of the independent variable. So now that we have significant results, from this t-test down here, knowing that our data was caused by the IV, we can actually make a conclusion on why. So I believe from my research that it was because of plasticity or change in the brain in the occipital lobe, the parietal lobe, and the temporal lobe, because these three areas have heavy influence in when person is in musical training or sight reading, because it's mostly visual and memory based. So I felt as though that the people who were musically trained had much more plasticity in these three ranges, and that has helped them assist them in deciphering the codes faster. So any form of error would be in these guys: rote versus note. Rote is learning through ear training, and note is learning through musical notation. And I did not factor this in when I was choosing people. Another error would be that the testing location sometime ranged when super quiet to super noisy, and that could have affected the concentration. Any recommendation for further study would be with fMRIs using functional magnetic resonance imaging to detect blood flow and map out the brain's activity. And this is great because it will show you exactly where the plasticity is happening. And this is just a graphic that shows, how it would work. And you can see that it would map out the plasticity. So I felt as though if I were to have access to this, it'd be a great way to extend the research.